Hi, this is Shannon Seaver, and we're looking at part 4 of Venn diagrams and set operations. This is from section 2-3 of your book. Today the agenda is looking at the meaning of and or from English to math, and to use the formula to find the cardinality of A union B. So on this first one, we're going to look at English and Venn diagrams. And first of all, I want to define that or actually refers to the union of two sets. So this would be A union B. And refers to the intersection of two sets, so that would be A intersect B. So to describe this further, I've broken this down into a series of sentences, and we're going to look at the Venn diagram and show what region they're actually referring to. In order to do that, you need to know, first of all, that set A is the set of EHS students that are going to the homecoming game, and B is the set of students going to the homecoming dance. Here we have 5 examples, and it would probably be a good idea to go ahead and write a Venn diagram for each example. So if you need to stop for the video at any time here, you should do that. So for looking at the first example here, EHS students who are going to the game and not the dance, excuse me, we're looking at and not. So going to the game, we know that A is going to the game. So we are looking at all of this section right here, but not the dance, because this middle section are the ones that are going to both. So if I were to write that on here, this would be section 1 and just section 1, excuse me. For the second part, EHS students going to the dance and not the game, it's the same idea, except it's on the other side of the graph. This is all the folks that are going to the dance but not the game. We're not including region 2 again. So this refers to only region 3. Okay. For this one, we have EHS students going to the dance and the game. So on this one, this refers to A intersect B. We're looking at purely region 2 in this, going to the dance and the game. So that would be section 2. All right. The next example is EHS students going to the dance or the game. That's referring to A union B. So that is going to be everything inside of this section. So that would be 1, 2, or 3. And the last one, EHS students going to the game. This is referring to everybody inside of B. All the students that are going to the game are in set B. So that would be sections 2 and 3. The next topic here is to find the cardinal number of the union of two sets. So how do I find the number of elements in both A and B? Well, here is the formula, and you need to write this down. The number of elements in both A and B are the number of elements in A plus the number of elements in B, subtracting the number of elements in A intersect B. Why do we do that? Well, let's go through this for a moment. Think about the regions that are in A we have 1 and 2. So I can say the number of elements would be the same as saying 1 plus 2. The number of elements in B would be the things that are in region 2 and 3. So I could say that's the same as saying plus 2 plus 3. Well, notice that we've added 2 twice. So the whole reason that we need to subtract the A intersect B is because we need to subtract out one of those. That's the reason why we subtract it. Let's look at a word problem that shows this in more detail. So we have some results of the Campus Blood Drive survey indicate that 490 students were willing to donate blood, 340 students were willing to help serve the free breakfast to blood donors, and 120 were willing to donate blood and serve breakfast. How many students were willing to donate blood or serve breakfast? So we want to look at A union B again on this. If we were to draw a Venn diagram, we'll say that A are the students willing to donate blood, and we know that there's a 490 of them total. And I'm just putting this on top. I'm not putting it inside because it's the entire circle. B are the ones that are willing to serve breakfast. There's 340 of them. And the intersect part, there's 120. These are students that are willing to do both. So the question was, what is the total inside the two circles together? So remember, we have A union B equals the cardinality of A plus the cardinality of B minus the cardinality of A intersect B. Well, they've given us everything we need for this problem. We know that there are 490 students in A, plus there's 340 students in B, and we need to subtract 120 students from the intersection of the two of them. So if we add that up together, we get 710. So there's a total of 710 students that are in A union B, or that are willing to donate blood or serve breakfast. So now I want you to pause the video and take time to try this one on your own. So just to set up the Venn diagram first, we know that the total amount of students in the school is 500. And the number that registered for math here is 244. The number that registered for English was 230. And the ones that registered for both were 89. Now in this case, we do not need to know the universe of 500, but there may be a problem later on that you may need to know that. So I went ahead and wrote it there. We need to find E and M union, okay? The elements of it. So the number of elements in M plus the number of elements in E minus the number of elements in M intersect E. We have 244 plus 230 minus 89. If you put that into a calculator, you're going to have 385. So 385 students were registered in math or in English class. So that's it for today. Thanks.